Hi everyone, before moving forward with this session, am I properly audible and is the screen visible? Can I be heard? Am I properly audible? Okay, all right. So with that
We
said,
cannot hear you. I think you're on mute.
can you hear me now? Can the students hear me now? Yeah, I think the students can hear me. All right, so we'll be promptly starting this session. Yeah. We'll be continuing where we left off last time. Last time we were discussing on different topics within quantitative aptitude. Today we're going to discuss on algebra, geometry, and number system. These three are pivotal in mathematics, really important topics in mathematics for your entrance exam as well as higher education. So I think I'll be able to provide you with very useful ideas in these topics concisely. So stay tuned for all of those. So with that said, let's straight up dive into the first topic, which is algebra. All right. So here I've noted down almost every basic algebraic formula that will come in handy while solving the problems. So I request every one of you to take a screenshot of this particular page, slide, and then we'll be moving forward with our formal discussion. All right, assuming every one of you took the screenshot of this particular slide, let's straight up dive into the practice problems. All right. The first question reads, if A over B plus B over A equals 1, the value of A cubed plus B cubed will be. So to solve this problem, you guys need to know the formula for A cubed plus B cubed. And I hope every one of you know that, right? So give this problem a try, send the answer in the chat box, then we'll be discussing further on this particular problem. All right, so the answers are quite mixed, right? Some are saying that the answer is 1, some are saying it's 2, some are saying it's 0. All right, so I'll be walking you guys through this problem as ASAP. All right, so take a look at this. We are given A over B plus B over A equals to 1, right? So once we sort of bring this formula, bring this equation into structure, we get A squared plus B squared equals to AB, right? Does everyone understand how this came about? We are taking the LCM in the left-hand side and multiplying the denominator of the left-hand side to the right-hand side. Does everyone get this, how this came about? All right, so with this, what we can further reduce this down to is A squared plus b squared minus ab equals to 0, right? So someone is saying that they did not get how this came about. So what we can do is, I'll further be explaining this. So what we do is we take the LCM, right? So we've got A here, we've got B here. So we take the LCM, which is AB, right? And so when this happens, there will be cross multiplication between these components. So it's going to be A squared plus B squared. And this is entirely equal to 1, right? And so next up, what we are simply doing is multiplying AB to the right-hand side. So we get this particular expression, right? So hopefully that's clear now. And from this, we move down to this form, a squared plus b squared minus ab is equal to 0. But what's the use of this particular expression, right? So we know the formula for a cubed plus b cubed is, let me write it down here, a cubed plus b cubed equals to a plus b, right? A plus b whole times a squared plus b squared minus ab, right? So this is the formula for a cubed plus b cubed. We know the value of a squared plus b squared minus ab, which is equal to 0, right? So with this, the entire right-hand side comes out as a plus b times 0, which is equal to 0, right? So the correct answer is option number B. Was this clear to everyone? Okay, so this was clear to everyone. So let's move on to the second problem. All right, so a few of you are not getting that particular problem. So let's go over it once again. So what we are doing is we are solving this equation into this particular form, right? Into this particular form. We're transforming this equation into this form. I hope you can do this because this is basic algebra. I think you're taught this in your high school, middle school, and lower levels. So I think you guys can bring this equation into this particular form. And once you bring it to this form, what you can simply do is you can go over the formula for a cubed plus b cubed, which is a plus b times a squared plus b squared minus ab, right? And we know the value of a squared plus b squared minus ab, which is 0, right? We solved it from this equation. And so the right-hand side comes out as a plus b times 0, which is equal to 0, because anything multiplied by 0 is equal to 0. Is that clear? Is that clear? All right. So let's move on to the second problem. Take a look at this. If p equals 99, then the value of this will be. Yep, absolutely. The answer is exactly as Samjana says. I'll be waiting for a few more replies. For a few of you guys to solve this, then we'll be going over the solution. All right, so the correct answer is, as most of you see, right? The correct answer in this case is option number B, which is 999,999, right? But how did we come about this? There are a few ways that you guys can solve this. First, you can simply brute force this using a calculator, but I'm not sure if you guys are allowed to do that in your examination. With that said, there's an algebraic way of solving this, a bit more mathematically fulfilling way, right? where calculator is not needed. So what you guys can do is you can multiply this expression directly. So you get p cubed plus 3p squared plus 3p, right? So you get this after multiplying this, right? After opening the bracket. And so what we do is we add 1, right? We add 1 and then we subtract 1, right? So with this done, what we are basically doing is we are changing this particular form, right? We're trying to change this particular form. Now we know the formula for a plus b whole cubed, right? A plus b whole cubed. A plus b whole cubed is equal to a cubed plus 3a squared b, right? Plus 3ab squared, right? Plus b cubed. This is the formula for a plus b whole cubed. And this particular expression is in the form of p plus 1 whole cubed, right? So this can be written as p plus 1 whole cubed, right? And then we subtract 1. Is everyone clear up to this point? All right, so what we are basically doing is we are multiplying these two expressions, p and p squared plus 3p plus 3, to obtain p cubed plus 3p squared plus 3p. We obtain expression up to this point only, right? And what we are doing after that is adding 1 and subtracting 1. Why we did this? We did this to bring this expression, these first 4 terms, into the form of p plus 1 whole cubed, right? So with this, we have brought this into this form now. P is given as 99. So 99 plus 1 will be 100. So this is 100 whole cubed minus 1, right? So 100 whole cubed is equal to 1. And then we have 6 zeros, right? 1 and 6 zeros. And we subtract 1 from this, which is equal to 9, 9, 9, 9, 9, 9. And that is the correct answer, option number B. Right? Did everyone get this? Did everyone understand this? All right. So for those of you who did not get this, I'll be going over this one last time, right? Take a look at this. We're expanding this bracket to obtain the expression up to this green mark, right? Then we're adding 1 and then subtracting 1. Why we did this? We did this to bring this first 4 terms, right, 1 included, to the form of p plus 1 whole cubed, right? Then we do p plus 1. Since p is 99, p plus 1 is 100, and we can easily compute powers of 100, right? Computing powers of 100 is significantly easier than computing powers of 99. So we are basically, our objective is to make this calculation as easy as possible. So we are simply adding 1 to 99 in this step, right? After bringing it to that particular form. And with that done, we simply solve it and get 99999 as the answer. So I hope this is clear to everyone now. All right. We are not just subtracting 1, we are adding 1 and subtracting 1. These both get neutralized to 0. So this does not really make a difference in this problem. So you guys have to be mindful of that as well. All right, so with this done, let's move on to the third problem in algebra. All right. So the answers in this are quite mixed as well. Some are saying B, some are saying D, but the majority of you are saying that it's B, right? And the correct answer is in fact B, but why is that the case, right? Let's quickly walk through this entire problem fast. So first we've got E minus B, E cubed minus B cubed equals 61. Now what we do is we bring this into the standard form, or we simply put this into the formula. So we know that E cubed minus B cubed is equal to E minus B, right? Whole times E squared plus AB plus B squared, right? And this is equal to 61. Now we know the value of A minus B, which is given as 1, right? So this comes out as A squared plus AB plus B squared equals to 61, right? Because A minus B is equal to 1. So with that done, we've completed the first part. Now we are also given A minus B is equal to 1, right? A minus B is equal to 1. So what we do in this case is we square on both sides. We square on both sides. Now, one thing to note in these sort of problems is that the approach that I'm taking right now might be quite different from the approach that you might have taken to solve this particular problem, right? In algebra, there are numerous ways of arriving at the same solution. So keep that in mind as well. And the way that I'm doing it is not the universal way of doing this. This is significantly easier for me, right? And this might be easier for you as well. But this is not the only way of doing this, right? You guys can use your own tricks, use your own formulas to obtain the particular answer, right? But the answer must match. So we expand the left-hand side, and this becomes A squared minus 2AB plus B squared, and 1 squared is simply 1. So we've got two equations, right? We've got equation number 1, this, and we've got equation number 2, this. Now what we do is we subtract 2 from 1. So 1 minus 2, right? This is equal to 3AB, right? So 3AB, this comes out as 3AB is equal to 60. When we subtract 2 from 1, right? So AB comes out as 60 divided by 3, which is 20. Was this clear to everyone? All right, it seems some of you are still confused in this. It's quite easy. All right, so take a look at this. What we did, it's a two-step process, all right? So first, we expanded A cubed minus B cubed in this form, right? In this form. This is the formula for A cubed minus B cubed. Now, we know the value of A minus B, which is equal to 1, right? So we simply put that, and then we get A squared plus AB plus B squared equals 61. And this we mark as equation number 1, right? Next up, we are given A minus B equals 1 as well. A minus B equals 1. And what we're doing is we're squaring on both sides, right? You guys must be familiar with this concept as well. When two quantities are equal, you can square on both sides. You can multiply by the same quantity on both sides. You can divide by the same quantity on both sides. That's a pretty fundamental concept in algebra, and you guys must know that to solve these types of problems, right? So with that said, we are squaring on both sides. Then we expand the left-hand side as A squared minus 2AB plus B squared, because that's the formula for A minus B whole squared. Right-hand side is 1. Now, we've got two equations, equation 1 and 2. What we are doing at the end is we are subtracting 2 from 1 to get A squared, B squared, and B squared cancel out. They subtract to 0, right? When you do that. And the only things left become A minus B minus, right? So AB, right? Minus 2ab remain, right? This is the intermediate step between those. And this is simply equal to 3ab, right? And the answer at the end, the value of AB comes out as 60 divided by 3, which is 20. Was this clear now? All right, so with this done, let's move on to the fourth problem of algebra. This problem reads x squared plus 5x plus 6 equals to 0, and we have to find the value of this. Now, there are a few ways of doing this. First, you can solve this particular equation, find the value of x, and then keep the value of x here. You'll be obtaining two values, and you put both the values and check which values matches with the answers in the options. Then you solve it, right? But that's a bit long, so I'll be taking the shortest approach. Notice how both of these equations, this one and the denominator here, have got x squared plus 6, right? So what we do is from this equation, we do x squared plus 6 is equal to minus 5x, right? So with this done, with this particular equation established, what we can do is in this particular fraction, we can do 2x over, right? X squared plus 6 can be replaced with minus 5x, right? Minus 5x minus 7x, because that's remaining here, minus 7x. And so this can be rewritten as 2x over minus 12x, right? And so x and x cancel out. 2 over minus 12 is equal to 1 over minus 6, which is minus 1 over 6. Option number C. Did you guys get this? Was this clear to everyone? All right. So with this done, let's quickly move on to the fifth problem of algebra. If a plus b equals this, a minus b equals this, then what's the value of this? I mean, this might be the easiest problem from among the ones that we have done up to this point. So let's quickly do this. We've got two equations, right? So we square both of them. From this, we get a squared plus 2ab plus b squared is equal to 25, right? Then from this, we get a squared minus 2ab plus b squared is equal to 9, right? So now, since we have to find the value of a squared plus b squared only, we can add these two, add these two equations, right? Then we obtain from there, we obtain 2a squared, right? A squared plus a squared is 2a squared plus 2b squared is equal to 25 plus 9 is 34, right? Now we take 2, we factor out 2 from the left-hand side, or take 2 as the common factor. Then we get a squared plus b squared is equal to 34 by 2, which is equal to 17, which is the correct answer, as most of you have answered in the chat box. Option number E, right? With this, I hope this question, this solution is understood by everyone. Most of you are engaging in the chat box, so I'm assuming yes. So with this done, let's quickly move on to geometry. This is a formula sheet for most of the formulae that are used in geometry, right? You guys can take a screenshot of this particular slide. This may come in handy when you're solving problems. All right, so assuming every one of you took a screenshot of this particular slide, let's move on to the practice problems. The first question. A cone and a hemisphere have equal bases and equal volumes. Find the ratio of their heights. To solve this problem, you guys need to know the formula for volume of cone and a hemisphere, right? Assuming you do, I think this question will be fairly easy. Yep. Redmi, whoever that is answering correctly in the chat box, right? All right, so the correct answer in this case is, as most of you guessed, right? It's option number B, which is 2:1. But why is that the case, right? So take a look at these two figures, right? These are representations of what a hemisphere and a sphere and a cone is. So sphere is basically a ball-like figure. Hemisphere is the half of sphere, exact half, right? And so this particular figure is a hemisphere, right? So the volume of a hemisphere will be exactly the half of that of a sphere. We know that the volume of sphere, which are represented by S, is equal to 4/3 pi r cubed, right? So the volume of hemisphere is going to be half of this, which is 2/3 pi r cubed, right? Next up, we know what a cone is. It's basically this figure, right? And the volume of a cone, which I'll be representing by C, is equal to 1/3 pi r squared h, right? So this h is the height of the cone, and in case of hemisphere, the radius is basically the height, right? Because that's the only parameter that we have, right? So with that, what we will be doing in this case is to find the ratio of their heights. And since we know that they have got the same r, right? Equal bases means that the radius of the base is the same. So r and r will be equal and their volumes are equal. So we can equate these two to get 2/3 pi r cubed is equal to 1/3 pi r squared h, right? So from this, the 3 and 3 in the denominator cancel out. R cubed cancel out with r squared, right? So we've got r left in the left-hand side, pi and pi cancel out. So we've got h/r is equal to 2 from this particular equation. From this we get h/r is equal to 2, or this can be written as 2/1. So the ratio of the height of cone and hemisphere is 2:1, right? Was this clear to everyone? All right. All right, so we'll be quickly moving on to the next problem. All right, so someone is spamming in the chat box saying that they're not clear with this particular problem. So for this problem, you need to know two formulae. First, the volume of a hemisphere, which is 2/3 pi r cubed. And second, the volume of a cone, which is 1/3 pi r squared h, right? So with that done, and the conditions that the question has, which is that the radius of their bases are the same, right? So we can simply write r as their radius in both of their cases. And we've got that their volumes are equal, so we are equating them in this particular step. So with that done, what we're doing is simply solving for h/r, because we have to find the ratio of their heights. In case of hemisphere, the height is basically the radius, because that's the height of the hemisphere from its center to the surface, right? So hopefully it's clear now. If it's not clear, then you will have to revise the formula and then come back to this problem once again, because the problem reads quite simple. And I think once the formula is established, you can easily solve this. With that done, let's move on to question number 2. The perimeters of two similar triangles ABC and PQR are 36 and 24. If PQ equals 10, then what's the value of AB? All right, so let's quickly solve this problem. Yeah. So take a look at this figure, right? So this is our triangle ABCD, and this is our triangle PQ, right? And R, PQR. So note that the order in this case must match, right? So ABC, it's moving in clockwise fashion, so PQR must also move in clockwise fashion. It was labeled as DEF, right? But I simply changed that to PQR. So that's basically it, PQ and R, right? So we know their perimeters, and we know the value of one of their sides, right? PQ. So we know in case of similar triangles, the ratio of their sides are proportional, right? So that is to mean, in this case, PQ over AB is equal to QR over BC is equal to RP over CA, right? So this relation is well established in terms of similar triangles, right? Am I audible now? Is my voice properly audible? All right, cool. So I'm audible. So this particular relation it happens only in case of similar triangles, right? Now we know the value of PQ over AB now. From this same ratio, proportions, what we can also establish is this entirely is equal to PQ plus QR plus RP all divided by AB plus BC plus CA. How did we do this? We simply assume that this is equal to K, and then we can solve it for this particular ratio. But just keep this ratio in mind. If ratios become equal in this fashion, then the sum of numerators and the sum of denominators is proportional to the previous ratios as well, right? So that's, with this established, what we can do is we can take this particular ratio PQ over AB and this last one, which is basically the ratio of their perimeters. PQ is given as 10 and AB is the value that we have to find, which is AB. And then PQ plus QR plus RP, the perimeter of PQR is given as 24. And the perimeter of ABC, which is AB plus BC plus CA, or the denominator of this fraction, is given as 36. So solving this, what we get is AB is equal to, this is 12 times 2, this is 12 times 3. So this is equal to 30 over 2, which is equal to 15. So the correct answer is option number A. Is this clear to everyone? All right, cool. So this was fairly simple. Let's move on to the third problem. A chord AB of length, this is at a distance of 4 kilometers from the center of the circle. The radius is this. So we've got a figure as well in this case, right? So AB is of length 20 centimeters. The distance from the center is 4 centimeters. We have to find the radius, or OA, in this particular case. All right, so let's walk through this problem. Yeah. What we do is we mark this particular point, or the point of intersection of the perpendicular distance and the chord, as D, right? So we know that ODA is a right angle triangle, right triangle, right? That's because this is the perpendicular distance from O to AB, right? Whenever it says distance from the center, then you guys have to remember that the distance that it's referring to is perpendicular distance. There's no other option here. So with that, we know a few values first, but before that, we have to know a certain theorem as well. The perpendicular from the center to a particular chord bisects the chord, right? So with that theorem said, AD and BD are going to be equal. And since AB is entirely equal to 20 centimeter, AD is going to be equal to 10 centimeters. So we've got 4 and 10. So the value of OA is going to be root under 4 squared plus 10 squared, right? Root under 4 squared plus 10 squared, which is, now from this, what we can do is we can write this as root under 116, right? We can write this as root under 116. And which is equal, which can be rewritten as root under 4 times 29, right? 4 times 29, because 4 times 20 is 80, and then we have to add 36 to get to 116. So this will be 2 root under 29, right? So option number B is the correct answer in this particular case. For those of you who did not get what I did here, what I'm doing here is I'm using a formula called Pythagoras theorem, right? You guys must be familiar with this as well. This is very vital in trigonometry, in most of your geometry as well, right? So note it down. If you guys don't know about Pythagoras theorem, you guys can find plentiful resources on the internet that explain what Pythagoras theorem is. But basically it mentions that the hypotenuse, or in this case, OA, which is the hypotenuse or the longest side of this right angle triangle, is equal to the sum of the squares of the other two sides, root under that entire thing, right? So the answer is 2 root 29 in this case. I hope this was clear to everyone. All right, so with this said, let's move on to question number 4. In this question, you will have to know a certain terminology, that is the circumradius, right? So I'll be explaining what circumradius is. Before that, take a look at this particular figure, right? A circumcircle, right? A circumcircle is a circle that passes through each of the vertex of a particular triangle, right? So for instance, this ABC, right? ABC is an equilateral triangle, and its circumcircle is this circle ABC, right? So circumradius, and if the center of this circle lies somewhere around here, the circumradius is basically the radius of this particular circumcircle, right? And that, with that said, we have to solve for the height of this triangle, right? Which is basically a perpendicular from one of the sides to the opposite side, right? So if I drop a perpendicular from here to D, this perpendicular passes through the center of the circle, which is O, right? And after this is done, all we have to do is solve for this perpendicular, right? Now we know a few things. First, we know that the circumradius of this equilateral triangle is 8 centimeters, right? So this is equal to 8, this is equal to 8 as well, right? And we also know that this circumradius bisects this angle C, right? So we know that an angle of an equilateral triangle is 60 degrees. So this is equal to 60 degrees. So angle OCD, or this angle, is going to be 30 degrees, right? So by using trigonometric ratio, what we can find is the length of this particular side, OD. So we know that sine 30 degrees is equal to OD, which is the perpendicular, over OC, which is the hypotenuse, right? Which is equal to OD by 8, right? OD over 8. So OD is going to be, sine 30 is 1 over 2. So 1 over 2 times 8, which is equal to 4, right? So we know OD and we know the length of OA as well. So AD is going to be 4 plus 8, which is equal to 12. Option number B. Was this clear to everyone? All right. So with this done, there are a few key concepts to keep in mind from this problem. First, the idea of circumcircle, and next up is the idea of circumradius. Then also note that the height of this equilateral triangle passes through the center. That is because height of an equilateral triangle bisects the base. And we also know from the chord theorem that the distance, or the perpendicular from the center, bisects the chord as well. So BC is bisected by both AD and OD. And so with that, it must be that AD passes through O, right? So with that said, and next up is the idea that this circumradius bisects the angle, right? Angle C in this case. And so with that done, we can simply use basic trigonometric ratios to solve for this particular problem. I hope this was clear to everyone, right? With those concepts established, I think it's fairly simple to solve this particular problem. With that done, we won't be doing this, we'll be doing this. All right, question number 6. In this case, what's the maximum number of tangents that can be drawn, is the question. Yep, the correct answer is exactly as Samjana says in the chat box. The correct answer is option number A, which is 3. That is because two tangents can be obviously drawn. One from the top side, right, which is a common tangent to both of these, right? And one from the bottom, which is a common tangent to both of these. But another one can be drawn, which passes through this particular intersection point, right? So in total, 3 tangents can be drawn. No other common tangents is possible in this particular figure. So the correct answer in this case is option number A, which is 3, right? I hope everyone is clear on this particular problem as well. So when 2 circles touch externally, 3 common tangents are possible. But in cases that they overlap, only 2 are possible, right? So they have to touch in order for 3 to be the total number of tangents possible. All right, so with this done, let's move on to number systems. So in number systems as well, the same previous formulas can be applied, right? The algebraic formulas. So I won't be going over these, but you guys can take a screenshot of this slide to revise on this later on. All right, assuming every one of you did take a screenshot of this slide, let's move on to the practice problems. Without using a calculator, try finding the value of this. Yep, absolutely. The correct answer is C in this case, right? So what we can do in this case is we can write this as 100 plus 15 whole squared, right? 100 plus 15 whole squared, because 115 times 115 can be written in this form, right? And we can write 85 into 85 as 100 minus 15 whole squared, right? And we know this is in the form of a plus b whole squared, and this is in the form of a minus b whole squared, right? And so the sum of these two, right, is going to be equal to 2 bracket 100 squared plus 15 squared, right? And we know that the value of 100 squared is definitely 10,000, right? 10 and 1 and 4 zeros. And 15 squared is a standard square value, which is 225, right? So this is going to be 20,000 plus 225 times 2 is 450, right? And so this is 20450, which is the correct answer, option number C. Right? Is this clear to everyone? All right. All right, so for those of you who are saying that there's a negative sign here, this is not a negative sign, this is simply a dash. All right, so don't get confused with that. That's a dash, not a negative sign. This is a dash as well, not a negative sign. All right, so let's solve this for y. Without using a calculator, try doing this because this is fairly simple as well. You have the correct answer is, as Roshan says in the chat, the correct answer is option number A, right? That is because, take a look at this particular thing, right? We've got 12,846 common in both of these expressions, right? So we can factor out that 12,846 bracket. So this comes out as 593 plus 407, right? And this sum is equal to 1,000, right? 593 plus 407 is 1,000. That's fairly simple. And so we've got 12,846 times 1,000 because bracket indicates multiplication. So this is equal to this thing, 12,846 000. Did everyone get this? All right. This was fairly easy as well. Let's move on to this. This is a bit conceptual, so you guys can take your time on this. Yep, the correct answer is 4, right? which is option number B. But why is that the case? The question asks, which of these following will always divide, right? Will always divide difference between squares of two consecutive even numbers completely, right? So there has to be no remainder in this particular case. So what we do is we assume one even number to be n, right? And so the greater even number or its consecutive even number is going to be n plus 2, right? Because even numbers lie at a common difference of 2. So now we have to square this because between squares of two consecutive even numbers. So, and then we subtract them. So this can be written as n plus 2 whole squared, right? Minus n squared. N plus 2 whole squared is n squared plus 4n plus 4 minus n squared, right? And n squared and minus n squared cancel out. So this is going to be 4n plus 4, right? And this can be rewritten as 4 bracket n plus 1, right? N plus 1. So with this 4 as a factor here, what we can see is if we divide this by 4, this 4 and this 4 are definitely going to be canceled out, and we are going to get a pure whole number as our answer, right? But if we divide this by any other number, let's say 3 or by 6 or by 7, then the probability of this being completely divided is completely dependent upon the value of n that we choose, right? But we want this to be divided always, right? In every case, even if when the n becomes something that cannot be divided by 3, 6, or 7, right? So 4 is the obvious choice in this one, option number B. Was this clear to everyone? Okay, so with this done, let's move to the fourth question. The sum of three consecutive numbers is 87. The middle number is. Absolutely. The correct answer is exactly as Sanjana points out in the chat box. It's 29, right? But why is that the case? Let us assume that the middle number is n, right? So the other numbers are going to be n minus 1, right? And n plus 1, because we are looking for three consecutive numbers. So these are consecutive. These three are consecutive numbers, n minus 1, n, and n plus 1, right? So with this, what we do is we add them because we have to find the sum. And we know that the sum is 87 as well. So we do 87 is equal to n minus 1 plus n plus n plus 1, right? So this minus 1 and plus 1 cancel out, and we get 3n, right? And basically the answer is n equals 87 by 3, which is equal to 29, right? So 29 is the middle number because n, we initially chose this as the middle number. Is this clear to everyone? All right, I'm assuming yes. So with this done, let's move on to the fifth question. The sum of four consecutive even numbers is 748. The smallest among them is. All right, so let's solve this, yeah? So let the first even number be n, right? And the other numbers will be n plus 2, right? This is going to be the second even number. Then we've got n plus 4, which is going to be the third consecutive even number. And then we've got n plus 6, right? So these four are consecutive even numbers, and their sum is 7, 4, 8, right? So we've got 4n plus 12 is equal to 7, 4, 8. So once you subtract 12 from both sides, we get 4n equals to 736, right? And n is equal to 736 divided by 4, right? 736 divided by 4, which is equal to 184, which is the correct answer in this case. Is everyone clear on this? Okay, so with this done, we come to the last problem of this particular section. Take a look at this, yeah? The sum of three consecutive even natural numbers divisible by 3 is 45. The smallest number is. So what we do is we assume that the smallest number divisible by 3 from among these three is n, right? So the second consecutive number divisible by 3 is going to be n plus 3, because they lie at a difference of 3 from one another. And the third one is going to be n plus 6, right, which is at a difference of 3 from the second one. And this entire sum is going to be 45, right? So this comes out as 3n plus 9 equals to 45, right? And this is 3n equals to 36. So n at the end comes out as 36 over 3, which is equal to 12, right? So this is the correct answer, option number A. Right, so most of you guessed this correct. Yep, definitely. The correct answer is A in this case, right? So with this done, we've come to the end of our session. I've included some useful resources which you guys can go over for more practice on these topics, right? So take a screenshot of this particular slide and go through these in your free time. With that said, thank you for being here, and I hope you learned something new in this session.